Hello everyone, and welcome to lecture 21. And we're going to talk about the binary junction transistor as a switch, and this is part 3 of this discussion. So in the previous couple videos, we built some simulations where we had a transistor, we had a switch, and a power source and a load. And one of the problems with it was, even though we got the transistors operational and made a cool circuit happen, it's not really any more efficient than just throwing a standard switch in and activating that and using resistors to manage the amount of current going through the circuit. So this is the lecture where we want to talk about really the advantage of the transistor. So the transistor is cool because we can use electricity to switch electricity. So rather than having to manually operate a switch, if we can get any electrical signal into the transistor, we can operate it and use it to switch. So this is a really important concept, and if you've taken classes in PLCs or motors or controls, or just in general, you might understand that relays do a similar thing, where you can have one circuit with a relay that can turn a relay on, which in turn activates a second circuit with a higher power. And the transistor can kind of operate in this way. So what we can do, for example, is if I have a thermocouple and connect that to my NPN transistor. So if this connects to the base of the NPN transistor, what a thermocouple does is it uses two different types of material, and when a flame or heat is near the thermocouple, it'll sense it and it'll generate current. And if we send current through the base of the transistor, we can use that thermocouple to activate the circuit. So to just give you a kind of a quick example, I'm going to draw one of these up. So basically, I can't actually put a thermocouple in this circuit, but what I can do is I can put multiple voltage sources, which is what a thermocouple would be. So in this case, we're going to leave it at 5 volts, and this one we're going to drop to, say, 1 volt. And we're going to add in our active component, which is our NPN transistor. It could be a PNP. We would just need to, make sure we're biasing it correctly. And we also want to go ahead and add in the LED, which again needs to be biased correctly. And finally, I'll add a switch, because it's always good to add a switch. And that allows us to control whether or not that thermocouple is active. And this small voltage is our fake sort of simulated thermocouple. And I believe I've done this correctly, but you can see now, in this circuit, the emitter is the most negative. The base is going to be in between the emitter, so it's got 1 volt basically at it, and the collector is going to be the most positive. So we can see here that's got 4.825 volts. This LED just has a chunk of millivolts, which is what the difference between that and the 5 volts is. So in theory, in this circuit, if this thermocouple, so to speak, senses a flame, it'll generate an electrical current that can control this. You can see this is actually moving a little bit quick. So I'm going to go ahead and actually reduce this even more by adding in a resistor. So we'll just add that in. I'll just make it 10,000 ohms just to see what that looks like. And that's maybe a bit much, so let's drop it to 5K. And you can see now we have a very, very little current going through the base emitter junction, but we have a fairly steady current of about 7 milliamps going through our LED and turning it on. So in this case, now we have one voltage that's controlling another voltage, and this is really where the power of transistors can start to be seen. So when we have, instead of just one voltage being controlled by a transistor, if you have one electrical signal or one current or one voltage that controls a whole another electrical signal or current, that's really where you start to get some really cool things happening. So that is really the main thing that we want to understand about switching in circuits. In the next video, we're going to start talking about amplification with BJTs.